Hello, my name is Tia Boyd, and I am currently a freshman at the University of Arkansas at Pine Bluff. I am majoring in mathematics education, and I'm excited to be here and be able to present to you a new method of learning calculus through coding. In this presentation, I will be discussing the integration of technology into our everyday lives, discussing what Julia is and how it is used, discussing what Cocao is and how it is used, explaining how using Cocao and Julia together can help us learn calculus, and then the overall benefits of learning calculus through coding. As you may know, the world is changing. Technology is becoming a bigger part of our lives, and this is happening each and every day. With this new change, there are concerns rising and different changes how the world functions. One of these is coding. Coding, because of how heavily digital and virtual our world is, coding is becoming a necessary job skill. You must know how to manipulate technology in order to be successful. Once again, and with these changes, as mentioned before, concerns are coming up. A lot of students are feeling unprepared for the real world, as they say, and unprepared to enter the workforce. We also have, because of technology and how it's heavily used, students are losing the ability to think critically. And this was actually cited in an article, Are We Losing Our Ability to Think Critically?, where Samuel Greengard had mentioned how computer technology is enhancing our lives, but that some experts believe it may be affecting people's ability to think deeply. And one reason that's cited is that most visual media is real-time media, which means that as it is occurring, we are viewing it. And because of how fast this happens, we're not allowed time for reflection or the ability to analyze this information, which in turn causes people to not think critically and think deeply, and also they fail to realize their full intellectual potential. So in order to combat these concerns and issues, we believe that by incorporating coding and programming into our curriculum will lead to students engaging these critical thinking skills that are important for everyday life, and then also the students are being prepared for the workforce because of their learning of coding and this new skill. So Julia. So what is Julia? Julia is a programming language that is high performance and dynamic, which basically means it acts very fast and it's able to meet everyone's need. So it can be used by a beginner or an advanced programmer. It's also, once again, used for general use, coming back to it's being very intuitive and beginner friendly, and it's open source, which means Julia is a free programming language. So it's very accessible to everyone. Now, the uses of Julia. Julia is a general purpose programming language. So there's various things you can do with it. One thing is numerical technical computing, which we use it for in calculus. You can use it for web programming, so designing a website, low-level systems programming, and developing apps and applications. Here is an image of the Julia interface. This example what it looks like. Next up is Cocao. So what is Cocao? Cocao is an online workspace that is separated into various projects, and it's open source, once again, meaning it's free and accessible. And one great thing about Cocao is that it is, you don't have to download Cocao in order to use it. It's provided to you within your browser, your website. So once again, it's highly accessible. So some uses of Cocao is for course management, or how my professor uses it, for general calculations. People use it for research in order to house their data. And then it's also used for collaboration. Cocao has a great feature to where multiple people can work on a single project. And once again, this is also used in my calculus class, as my professor and one of our PLTL leaders has access to our different projects of each student to do their work. So here's an example of what Cocao would look like. This is just one project. For example, as you can see, you can create graphs in it, 3D imaging. You can put in different functions, different numerical and mathematical computations. So how do we use Julia and Cocao together in order to learn calculus? In my class, the main way we do it is through the Jupyter Notebook. As I mentioned before, Cocao hosts different programming languages and programs that you can use when you create a project. One of these things you can use is a Jupyter Notebook, which is basically, as it says, a notebook, but it houses 3 different programming languages. It houses Julia, the one that I use within my class, Python, and R. So in this one notebook, you have 3 different programming languages that can be used and that it will understand. And it allows us to do these different complex calculations through simple code. So that's how we use an tangent in order to teach calculus. This is an example of one of our homework problems, Newton's method. And here you can see just how clean and simple it looks. For example, when you want to open a certain package, which you have to do in order to graph and use it for mathematical computations, you just type in using plots or using SymPy or whatever package you're going to use. And then, for example, for writing function, there's no weird syntax you have to put in. You just write your function how it is on your worksheet, or if you were doing this by hand, just type out your function. You can assign values such as x_1 equals 0. You can create intervals in it, and that which stands for x is equal to 1 to 2.5 in increments of 0.1. Also allows you to input all those x values into your function, which is in the very last line of code there. And I followed it up with a semicolon to keep it neat, and basically the semicolon condenses all of your outputs. So it just keeps your coding looking neat and not too difficult to follow. Here's another example of just showing how, once again, intuitive and beginner-friendly Cocao and Julia is as a programming language. Here is an error listed. In other programming languages, sometimes it will not show an error. It will just run through whatever your code was, and you'll just realize that it didn't do what you wanted it to do. So, but unlike that, Julia tells you, and in the Jupyter Notebook it tells you, and it actually tells you which line it's in. Some programming languages don't do that. For this one, it tells us what it is. It's a syntax error, and it explains to us what the error is. So it's a space before parentheses not allowed in plot. So the issue with this line of code is that I have a space in between plot and the parentheses. And all I would have to do is fix that, is delete that space and run it, and it would give me a graph of graph. So just some benefits of learning calculus decoding is that it offers a new point of view of looking at math. It allows you to visualize abstract concepts going back to that graphing function, and especially with Newton's method, using estimations and tangent lines. If you were doing that by hand, you wouldn't really have the opportunity to see how that tangent line is getting closer and closer as an estimation to that root of the function. And if you were to do that by hand, it would take hours of trying to find plots for that tangent line and going through all those steps. But through coding, it's just at your fingertips. Once again, you can practice your coding skills when you're learning. Through coding, you have to code in order to do it, and that allows you to practice. It provides real-world application of mathematic ideas. So as my professor put it, we become the programmers, we become the engineers. So we get to get a little peek of that kind of job, or other jobs that use coding and programming, and see how heavy technology is in these jobs, and how we can use, and how heavy math is within these jobs, and how they work together in order to help solve the issues. And once again, coding helps you develop critical thinking skills. And not only that, but in a another study called Learning to Code or Coding to Learn, a systematic review. The study had reviewed research to analyze educational outcomes for children learning to code at school. And besides the benefit of learning to code, they also observed other educational outcomes that was learned and practiced through the teaching of coding. These included mathematical problem solving, critical thinking, social skills, self-management, and academic skills. They also learned and practiced higher and lower order thinking skills while coding. So not only were they engaging at a very basic level of memorization, comprehension of the code, but also going up to that higher level of analyzing, evaluating, and creating and problem solving learning code. I would like to acknowledge my professor, Dr. Harris, and the National Science Foundation Historically Black Colleges and Universities undergraduate program targeted confusion project grant with the award number 2010292. And here are my references and the different studies I mentioned. Thank you for listening to my presentation. I'm now open for questions.